For these last four questions, we're integrating a few different things here. We're integrating logs that are not natural log. So here we have a log base 7 for number 10 and a log base 2 for number 11. And the other thing we're doing is we're going to integrate exponentials that, again, aren't dealing with the natural number e. So it's not e to the x, it's 3 to the x. These are both derived using natural log, So here we go. We have the two formulas here that you should know. And for number 10 here, we're taking natural log, or integral of log base 7, 2x dx. We have this 2x here, so we're going to go ahead and use u substitution. So we're going to let u equal 2x, which means du is simply 2 dx. And then we're going to integrate that. So integral of log base 7 of u, and then we want to get rid of this dx, so we can think we can divide both sides by 2 or divide both sides by a half, or multiply by a half, and this would give us 1/2 du equals dx. So we can take out a dx and put in a 1/2 du. We put the 1/2 out here and the du here, and then we can go ahead and use our formula for integrating this, which we have the 1/2 out front, and then we have the integral is going to be equal to this up here. So this is 1 over the natural log of a, which in this case is 7, times, and this isn't, we're not using x, we're using u, remember, so u times the natural log of u minus u plus c. And we do want to substitute back in, so we have 1 over 2 times the natural log of 7, and then our u up here, remember, was 2x, so we have 2x, natural log of 2x minus 2x. So this is pretty interesting here because we have a 2 here in both of these, and so that 2 cancels with this 2 because we could factor out this 2 and then cancel. So the 2 really didn't make a big difference on the outside. In the natural log we still have a 2, but so we have 1 over the natural log of 7 times x times the natural log of 2x minus x plus c. And there's the answer. For the next one, this one's actually going to be a little simpler because it's just an x within the logarithm. So we can really just move this 5 outside here and think through our formula. Let's change this so don't get confused here. We have, we'll rewrite it, 5 log base 2 of x dx, and we're just putting in our formula. So we have a 5 on the outside. In fact, we can put that right over our natural log, so 5 over the natural log of a, which is 2, times x natural log of x minus x plus c. And there's your answer. Nice and simple. And coming to the last ones here, here is the integral of an exponential. Simply the same exponential divided by the natural log of whatever the base was. In both these cases, we have an extra constant along, so this one we can write as -4 times the integral of 3x dx. And so this is, just as we said, we're going to just put it right in here. So this is going to be 3 to the x over the natural log of 3 plus c. And very similarly, we can bring the 2 out. So 2 times the integral of 5 to the x dx, which is going to be 2 times 5 to the x over the natural log of 5 plus c. I guess I should show that you can just write 2 times 5 to the x over the natural log of 5 plus c, but do not multiply 2 times 5 because obviously you do exponents first when working with the order of operations. So there